Welcome to your deep dive. Today, we're going to be diving into the science behind auroras.
Auroras.
You know, those mesmerizing lights that dance across the night sky.
Yeah.
We've got some fascinating research here, not just about the physics of how they form,
Right.
but also how auroras might exist on other planets
Yeah.
and the impact they've had on different cultures throughout history.
It's amazing how auroras bridge the gap between science and art.
Yeah.
They inspire both rigorous scientific study and just incredible artistic expression.
Yeah.
We'll explore not just what they are,
Right.
but why they matter,
Yeah.
why they've captivated humans for centuries.
All right, so before we get into the why,
Yeah.
let's start with the what.
Okay.
I know there are lights in the sky.
Right.
But what exactly are auroras, and where do they occur?
Auroras are colorful displays of light that happen primarily in the high latitude regions of our planet,
Yep.
both north and south.
Okay.
Imagine shimmering curtains or swirling spirals of light stretching across the sky. We call them the Aurora Borealis, or northern lights in the north,
Okay.
and the Aurora Australis, or southern lights in the south.
The northern lights, I've seen pictures, and they're absolutely stunning.
Oh, yeah.
Definitely on my bucket list to see them in person.
Yeah.
So what exactly causes these incredible light shows?
Well, it all starts with the sun.
Okay.
Our sun is constantly emitting a stream of charged particles called the solar wind.
Okay.
These particles travel at incredibly high speeds, and when they reach Earth,
Right.
they interact with our planet's magnetic field.
Okay. Now that you mention it, remind me about Earth's magnetic field.
Sure.
It's one of those things I learned about in school,
Yeah.
but could use a refresher on.
Think of Earth's magnetic field as a giant, invisible shield surrounding our planet.
Okay.
It protects us from the harmful radiation of the solar wind, deflecting most of it away.
So if the magnetic field is deflecting most of the solar wind,
Right.
how does any of it get through to create the auroras?
That's where things get really interesting.
Yeah.
While most of the solar wind is deflected,
Okay.
the Earth's magnetic field lines actually converge at the poles.
Uh-huh.
Think of it like funnels at the north and south ends of our planet.
Right.
Some of those charged particles manage to sneak in through these openings.
So particles get through at the poles.
Yeah.
What happens then?
When these charged particles from the sun collide with the atoms in Earth's upper atmosphere,
Yeah.
something amazing happens.
Okay.
They transfer their energy to those atoms, causing them to become excited.
Okay, so we've got excited atoms. What does that actually mean?
Yeah.
And how does it lead to the auroras?
It's all about energy levels.
Okay.
When an atom gets excited, it means one or more of its electrons jump to a higher energy level,
Uh-huh.
but they can't stay there forever.
Right.
Eventually, the electron falls back down to its normal energy level.
Right.
And when it does, it releases energy in the form of light.
Okay.
That light is what creates those amazing aurora colors.
So it's like a cosmic energy transfer from the sun to the atoms in our atmosphere.
Exactly.
And that results in those dazzling colors.
Yeah.
That's pretty mind-blowing. Speaking of colors,
Yeah.
I've noticed that auroras come in different shades.
Yeah.
What causes that?
The color of the aurora actually depends on which gas in the atmosphere the solar wind particles collide with
Okay.
and how much energy is involved.
Got it.
For instance, oxygen typically produces green and red light,
Nah.
while nitrogen emits blue and purple hues.
So the different colors are like fingerprints for the different gases in our atmosphere.
Yeah, you can think of it that way.
That's fascinating. Does this mean that auroras on other planets, if they exist, would look totally different from ours?
That's a great question, and it leads us to one of the most intriguing aspects of aurora science.
Okay.
Auroras aren't unique to Earth.
What?
We've actually found evidence of auroras on other planets in our solar system,
Really?
particularly those with strong magnetic fields like Jupiter and Saturn.
Auroras on other planets. That's amazing. What would they look like? Are they the same as Earth's auroras?
Here's where things get really interesting.
Okay.
Since other planets have different atmospheric compositions and magnetic field strengths,
Right.
their auroras would definitely look different.
Okay.
Imagine a planet with a predominantly methane atmosphere, for example.
Okay.
The colors and patterns of its auroras could be unlike anything we see on Earth.
That's a wild thought.
Yeah,
It really puts into perspective how vast and diverse the universe is.
absolutely.
But let's bring it back to Earth for a second.
Okay.
I mean, these auroras have been around for ages.
Yeah.
I imagine different cultures have developed some pretty interesting stories and myths
Oh, yeah.
to explain them, right?
Absolutely.
Oh.
Throughout history, auroras have been woven into the mythology and folklore of cultures around the world,
Okay.
especially those in high-latitude regions where auroras are most common.
I bet there are some pretty captivating stories out there. What are some of the ways different cultures have interpreted the auroras?
One that always stands out is from Inuit mythology.
Okay.
They believed that the auroras were spirits of the dead,
Wow.
playing a game of ball with a walrus skull in the sky.
Wow. A game of ball with a walrus skull in the sky.
Yeah,
That's definitely a story that would stick with you.
it is.
It shows how these lights have inspired people to create stories that connect them to the cosmos.
Yeah,
But I'm also curious about the science behind these auroras.
right?
What are some of the things scientists are still trying to figure out?
There's still so much to learn.
Yeah.
Scientists are working to better understand auroras in all sorts of ways.
Okay.
They're developing sophisticated models to predict when and where auroras will occur,
Okay.
and studying the impact of auroras on Earth's atmosphere.
Why is that research so important? Does it affect us here on Earth in any way?
It definitely does.
Okay.
Auroras are a visible sign of space weather, which can have a major impact on our technology. Powerful geomagnetic storms caused by solar activity can disrupt satellite communications, GPS systems, and even power grids.
So studying auroras isn't just about understanding a beautiful phenomenon.
Right.
It's also about protecting our technology from the potentially harmful effects of space weather.
Exactly.
That seems pretty crucial in our increasingly tech-dependent world.
Absolutely.
We've talked about the science behind auroras and their cultural significance.
Right.
But has anyone ever tried to harness the energy of the auroras? Is that even possible?
That's a fascinating question, and it's not something that's been explored very expensively.
I see.
But there have been some intriguing ideas about potentially tapping into the energy associated with auroras.
Like what? Give me some examples.
One concept involves using antennas to capture the electromagnetic energy generated during auroral displays.
Okay.
This energy could then be converted into usable electricity.
Hmm.
It's still in the very early stages of theory, but it's a pretty thought-provoking idea.
That's wild. Imagine powering our homes with the northern lights.
Yeah.
It sounds like science fiction.
Yeah.
But are there any major challenges to making something like that a reality?
Quite a few, actually. The
Right.
energy density of auroral displays is fairly low,
Right.
so you'd need a huge collection area to capture a significant amount of energy.
Okay.
Plus, auroras are unpredictable and transient,
Right.
which makes them difficult to rely on as a consistent power source.
Yeah.
And then there's the challenge of building and maintaining infrastructure
Yeah.
in the harsh environments where auroras are most prevalent.
So while harnessing the energy of auroras might be a long shot for now,
Yeah.
it's still a really cool concept.
Absolutely.
It highlights how creative people can be in searching for new and sustainable ways to power our world.
Yeah, exactly.
It's amazing how something so visually stunning could have such practical implications.
Yeah.
So next time I see a picture of the auroras, or hopefully get to witness them myself, I'll have a much deeper appreciation for the incredible science and cultural history behind them.
Absolutely. Auroras remind us that we're part of a much larger interconnected universe,
Yeah.
constantly buzzing with energy and activity.
Yeah.
And who knows what other secrets about auroras are waiting to be uncovered. That's the beauty of science.
Yeah.
There's always more to explore. It really is remarkable how something like a scientific phenomenon can spark such imaginative storytelling in different cultures.
It's like our way of connecting with the universe and trying to find meaning in the things we observe.
And those cultural interpretations can be so diverse.
Right.
It really reflects the unique beliefs and perspectives of different societies throughout history.
You mentioned the Inuit story about spirits playing ball with a walrus skull.
Yeah.
What are some other examples of how cultures have incorporated auroras into their beliefs and stories?
In Norse mythology, the auroras were thought to be reflections of the Valkyries,
Okay.
these female figures who decided who lived or died in battle. They were said to ride across the sky carrying fallen warriors to the afterlife.
Wow, that's powerful imagery.
Yeah.
You can really sense the reverence and awe that ancient cultures had for these celestial displays.
Absolutely. And there's also a Finnish folktale
Okay.
that attributes the auroras to a magical firefox
A firefox.
called the Revontulet.
Okay.
They said this firefox ran so fast across the snow
Wow.
that its tail created sparks of fire in the sky.
A firefox creating the northern lights. That's a fantastic visual, especially for people living in areas where auroras are a common sight.
Oh, yeah.
It really shows how these stories weave together nature mythology and the human experience.
It
It's
does.
a way of offering explanations for the inexplicable and connecting people to something larger than themselves.
Exactly. Even today, with all we know about the science of auroras,
Right?
there's still this sense of wonder and mystery surrounding them.
Yeah.
They continue to inspire artists, musicians, and writers
Right.
who capture their beauty and ethereal quality through various forms of expression.
It seems like the auroras are a bridge between science and art, reminding us that the pursuit of knowledge and the appreciation of beauty can go hand in hand.
I think so.
Speaking of scientific pursuit,
Yeah.
what's the current state of aurora research? What are some of the key areas scientists are exploring right now?
One of the most intriguing areas is understanding the complex interactions
Okay.
between the solar wind, Earth's magnetic field, and our atmosphere in even greater detail.
We've talked about those interactions creating the auroras,
Right.
but what are some of the specifics scientists are trying to unravel?
They're investigating the mechanisms of how energy is transferred from the solar wind
Okay.
to those particles in Earth's atmosphere.
Right.
They're looking at how the magnetic field lines guide and accelerate those particles, and they're trying to pinpoint the precise conditions that lead to the formation of different types of auroral displays.
It's like they're peeling back the layers of a cosmic onion,
Yeah.
revealing all these intricate processes at play.
That's a great analogy. And as scientists gain a deeper understanding of these processes,
Right.
they can develop more accurate models to predict when and where auroras will occur.
Okay.
That's particularly crucial for space weather forecasting.
Speaking of space weather, we touched on it earlier,
Yeah.
but I'd love to understand its importance a bit better.
Okay.
How do auroras fit into that bigger picture?
Space weather refers to the conditions in space that can affect Earth and its technological systems.
Okay.
Auroras are a visible manifestation of space weather driven by solar activity.
And what are some of the ways space weather can impact our technology and daily lives?
Well, as we mentioned before, intense geomagnetic storms, often triggered by solar flares or coronal mass ejections,
Right.
can disrupt satellite communications, GPS systems, and even power grids.
That sounds pretty serious. What kind of consequences can those disruptions have?
In extreme cases, they can lead to widespread communication outages, navigation errors, and even power blackouts.
Well,
This can potentially impact critical infrastructure and services that we rely on.
so it's not just about pretty lights in the sky. Auroras can signal more significant events that impact our lives in very real ways.
It is.
It's a reminder that our planet is connected to the sun
Right.
and that solar activity can directly affect us.
Precisely. Understanding and predicting space weather is crucial for mitigating those risks and protecting our technological infrastructure.
So how do scientists keep track of and predict these space weather events?
They use a combination of instruments both on Earth and in space
Okay.
to observe the sun and its activity.
Right.
They track things like solar flares, coronal mass ejections, and changes in the solar wind.
Okay.
Using this data, they can create forecasts and issue alerts when necessary.
It sounds like a constant game of cosmic cat and mouse trying to stay one step ahead of the sun's unpredictable behavior.
You could say that, but thankfully scientists have made incredible strides in space weather forecasting.
Okay.
We're getting much better at preparing for and minimizing the impacts of solar storms.
That's reassuring to hear. So the next time I see an aurora, I'll be looking at it with a whole new level of appreciation.
Yeah.
It's a reminder of this dynamic relationship we have with the sun and how it affects our planet.
Exactly. While they can be a sign of increased solar activity, auroras are also a beautiful testament to the protection provided by Earth's magnetic field.
It's like a cosmic dance.
Yeah.
This delicate balance between the sun's energy and the protective embrace of our planet.
What a beautiful way to put it. It really does highlight the interconnectedness of our solar system and the forces that shape our world.
You know, we've talked about the potential negative impacts of space weather.
Right.
But I'm curious about something. Are there any positive aspects to these solar interactions?
That's a great question. While space weather does present challenges, there are also some fascinating and beneficial effects.
Okay.
Obviously, the charged particles from the solar wind are responsible for those amazing auroral displays we've been talking about.
Right. But besides the visual spectacle, are there any other positive effects?
Believe it or not, space weather actually plays a role in shaping our climate and atmosphere.
Really?
Solar activity can influence cloud formation and affect the amount of radiation that reaches Earth's surface.
So it's not just about technology and infrastructure. Space weather has implications for the environment as a whole.
Absolutely. It's a reminder that Earth is an integral part of a larger cosmic ecosystem,
Right.
and that the sun's influence extends far beyond just providing light and warmth.
It's a humbling thought to consider that our planet's climate and atmosphere are influenced by forces happening millions of miles away.
It truly is. And it underscores the importance of understanding space weather and its potential impacts, both the positive and the negative, on our world.
Now, going back to culture for a moment, I'd love to explore the significance of auroras in a little more detail.
Okay.
We've touched on some myths and legends,
Right.
but how have these celestial displays impacted human art, music, and literature throughout history?
That's a fascinating area to delve into. Auroras have been a source of inspiration for countless works of art, music, and literature across cultures and time periods.
Are there any specific examples that come to mind of artists or writers capturing the essence of auroras in their creations?
One of the most notable examples in art is the work of the Norwegian painter Edvard Munch.
Okay.
It's believed that his iconic painting, The Scream, was inspired by a particularly vivid auroral display he witnessed.
Wow, I can definitely see the connection.
Yeah,
The swirling lines and vibrant colors in the scream do evoke a sense of the aurora's ethereal beauty and intensity.
they do. And in music, the Finnish composer Jean Sibelius was deeply inspired by the auroras. His Symphony Kullervo features passages that are said to musically evoke the shimmering dancing lights of the northern lights.
It's amazing how these natural phenomena can be translated into such powerful artistic expressions.
Indeed. And in literature, the auroras have been a recurring motif,
Okay.
often symbolizing mystery, wonder, and the vastness of the cosmos.
Are there any particular literary works that come to mind where auroras play a prominent role?
One example is the novel The Golden Compass by Philip Pullman.
Okay.
The auroras are actually a key element of the story,
Wow.
serving as a gateway to other worlds and representing the interconnectedness of all things.
It's fascinating how auroras can be used as a literary device to represent not only natural phenomena, but also these more abstract concepts like interconnectedness and venturing into the unknown.
Exactly. They have this power to transcend their physical manifestation
Right.
and become symbols of something greater.
Yeah.
Whether it's the beauty of nature, the mysteries of the universe, or the power of the human imagination.
It's a reminder that science and art aren't mutually exclusive.
Yeah.
They can complement and enrich each other, offering different perspectives on the same phenomena and inspiring us to explore the world around us with both curiosity and creativity.
I agree.
What about the future of aurora research? Where do you see the field going in the coming years?
One area that I'm particularly excited about is the exploration of auroras on other planets.
We touched on that briefly before,
Did.
but I'd love to dig a little deeper into what we know about auroras beyond Earth.
As we discussed, auroras have been observed on planets with strong magnetic fields like Jupiter and Saturn.
What makes these extraterrestrial auroras different from the ones we see on Earth?
The key difference lies in the composition of their atmospheres and the strength of their magnetic fields.
Okay.
For example, Jupiter's auroras are much more intense than Earth's due to its massive magnetic field and the presence of volcanic gases in its atmosphere.
So it's like a cosmic light show on a whole other level.
You could say that. And the colors of these extraterrestrial auroras can also be different,
Okay.
reflecting the unique chemical makeup of each planet's atmosphere.
It's incredible to think that these amazing displays are happening on other worlds millions of miles away.
It really is. And as we continue to explore our solar system and beyond, we're likely to discover even more diverse and awe-inspiring auroral phenomena. It just goes to show that the universe is full of surprises, and we're only just beginning to scratch the surface of its wonders.
Another area you mentioned earlier was the development of more sophisticated models to predict auroral activity.
Yeah.
Why is it so important to have more accurate predictions, especially considering what we've learned about space weather?
As our reliance on technology keeps growing, so does our vulnerability to the impacts of space weather.
Right.
More accurate auroral predictions can give us a heads up,
Okay.
allowing us to anticipate and hopefully mitigate potential disruptions to things like satellite communications, GPS systems, and power grids.
So it's really about protecting our technological infrastructure and ensuring that our increasingly interconnected world can keep functioning smoothly.
Precisely. And with advancements in computing power and data analysis techniques, scientists are making great progress in developing increasingly complex and accurate models to forecast auroral activity.
It's almost like having a crystal ball for space weather, allowing us to see what's coming and adapt to the sun's ever-changing behavior.
That's a great way to put it. These improved predictions will be essential for future space missions,
Right?
as well as for protecting our technological systems here on Earth.
It's amazing to think that something as seemingly ethereal as auroras can have such tangible and significant impacts on our lives.
They can.
It really underscores the interconnectedness of everything in our world and the importance of scientific understanding as we navigate the challenges and opportunities of this century.
I couldn't agree more. As we push the boundaries of space exploration and technological innovation, the study of auroras will become even more critical.
It's a great reminder that the pursuit of knowledge is an ongoing journey, a journey filled with wonder discovery and the potential to shape a better future for us all.
It really is incredible to think that something as seemingly simple as charged particles from the sun interacting with our atmosphere can create such a complex and captivating phenomenon.
It reminds you that the universe is full of surprises, and that even the most familiar things can hold hidden depths and wonders.
And as we continue to explore and study auroras, I'm sure we'll uncover even more fascinating insights and perspectives.
Speaking of perspectives, I've been thinking about something as we've been discussing all this.
Okay.
We've covered the scientific and cultural viewpoints on auroras,
Right.
but is there a philosophical perspective as well?
Mm.
What do auroras teach us about our place in the universe and the nature of reality?
That's a profound question.
Yeah.
In a way, auroras embodies the interplay between the vastness of the cosmos and the fragility of our own planet.
I'm not sure I follow. What do you mean?
Well, they're a constant reminder that we're just a small part of this much larger system, subject to forces that are ultimately beyond our control.
Okay.
But at the same time, auroras also highlight the incredibly unique conditions here on Earth
Right.
that make life possible in the first place.
It's like this cosmic dance, a delicate balance between the power of the universe and the preciousness of our own world.
Exactly. And it's a balance that we often take for granted.
Yeah.
Auroras can serve as a powerful reminder to appreciate the beauty and wonder of our planet
Right.
and to protect the delicate ecosystem that sustains us.
It's almost like a call to action, reminding us that we're not just passive observers, but
Mhm.
active participants in this grand cosmic play.
I like that.
You know, throughout our conversation, I've been struck by this recurring theme of interconnectedness.
Interconnectedness. In what way?
Well, we've talked about how auroras are the result of this interaction between the sun and Earth,
Right.
how they're influenced by space weather, how they've inspired cultures all over the world,
Yeah.
and ultimately how they connect us to the vastness of the cosmos.
You're absolutely right. It all points back to the idea that we're not isolated beings.
Yeah.
We're part of this intricate web of relationships that extends far beyond our immediate surroundings.
It's like the auroras are a visible manifestation of that interconnectedness, a reminder that everything is linked in some way.
That's a beautiful way to put it. And that sense of interconnectedness can be both humbling and inspiring at the same time.
Humbling in the sense that we're just a tiny part of something much greater,
Yeah.
but inspiring in that we're all connected, and our actions can have ripple effects throughout that web of life.
I agree.
This has been such a fascinating deep dive. Thank you for sharing your expertise with me.
It's been my pleasure. Auroras truly are a captivating phenomenon, and there's always more to learn and explore.
Before we go, I have one last thought-provoking question for you and for our listeners.
Okay.
If we could send a message to extraterrestrial civilizations using the auroras, what would that message be?
Wow, what a question. It really challenges us to think about what's truly important, what message we want to convey to other beings who might be out there observing us.
Imagine using that canvas of the night sky, those shimmering curtains of light, to create a message of peace, unity, or even just a simple hello.
It would be like a cosmic beacon, a testament to human ingenuity and our desire to connect with others beyond our own planet.
It's a beautiful thought to end on. Even amidst the vastness of the universe, we're not alone in our search for meaning and connection. Well, on that note of cosmic connection and the enduring allure of auroras, I think we've reached the end of our deep dive.
It's been a fantastic journey exploring the science, the culture, and the mysteries of auroras.
To our listeners, thank you for joining us on this exploration. We hope you've enjoyed it as much as we have. And remember, as you look up at the night sky, that the universe is a canvas of infinite beauty and endless possibilities for discovery. Keep looking up and keep exploring.